Systems of equations today. We're going to talk about the two main methods we're going to be using called substitution and elimination. Now, eventually you'll be able to have your pick and you can choose which one, but you need to be able to do both systems solving methods, and that's why we're going to show both of them right now. All right, substitution. One of the nice things about these two names is that they're logical. In substitution, you're literally going to be substituting a value into another equation. So as I look, I have negative 2x plus y equals negative 1, and x plus 2y equals 3. First step, you need to decide which variable you're going to isolate. You have to get one variable isolated before you can start anything with substitution. So notice that the y is going to be really easy to isolate, and so will the x. No difference. I'm going to choose the y. So in order to get my y isolated, I'm going to add the 2x. So notice this first equation will become y equals 2x minus 1. Okay? Very simple. Here's where the substitution happens. I take what y is equal to and I substitute that in to the other equation. So when I rewrite the second equation, it's now x plus 2 times y, but my y is 2x minus 1. Notice it was substituted in for the y value. And now we just solve. We get x plus 4x minus 2 equals 3. I bring the negative 2 over, we get 5 and 5x. So x equals 1. Now be careful, you're not done though. We're trying to find out where these two functions would intersect. What is a coordinate point that they share? Also, there's two variables, which means you need to find two answers. Well, if I want to find y, I might as well use the equation where y is equal. And now I get to substitute again. 2 times, not x. I know what x is, so I can substitute its value in. And we get y equals 2 minus 1, so y is also 1. So my final answer here is 1, 1. I list the x value first because it comes first in the coordinate pair, y value second. Also, just in case we need a reminder, because they intersect and form an actual coordinate point for their solution, this would be classified as consistent independent. All right, let's take a look. Another problem. Now this time we're going to be using elimination as our solving method. The object for elimination, now remember, in substitution, your first thing is you have to get a variable isolated. With elimination, the way I teach it, you have to get opposite coefficients. You have to decide which variable you want to eliminate and work towards getting opposite coefficients. If you'll notice, I have 6x plus 3y equals 6 and 8x plus 5y equals 12. Now, it doesn't matter which variable you're going to eliminate. I'm going to choose to eliminate x. I'm going to choose to eliminate x. Well, if you look, 6 and 8 are not opposite coefficients. So I need to find the LCM, least common multiple of these. Well, I know that 6 and 8 both go into 24. That's the smallest number they both go into. Now, I know a lot of students are going to want to try to go to 48. You can still get the right answer. You're going to be dealing with some big numbers. Make it easy on yourself. So if I want these both to become a 24, keep in mind one of them has to be negative so that I'm going to be adding down and eliminating it. That's my goal. So I'm going to multiply the top by 4 and the bottom by negative 3. This is a way I can manipulate my equations and get them to cancel. So my first equation will now become 24x plus 12y equals 24. Notice I distributed the 4 to everything. That's very important. Second equation, I get a negative 24x. Hey, that's what I wanted. That's what I wanted. Minus 15y equals negative 36. Okay, we distributed, got them all set, ready to go. Once you have opposite coefficients, you can add down. And this is where we get our name, elimination. They will be eliminated as I add down, and I'm left with a negative 3y equals negative 12. What an awesome, easy equation to solve. Divide by negative 3, y equals 4. Now, same thing. This is a systems of equations. We're looking for a coordinate point. It means an x and a y value. I have the y value, I have to plug back in. Doesn't matter which one I plug it into. The first equation looks like it has some smaller numbers, so I'm going to plug back into that one. So instead of 6x plus 3y, I'm going to make it 6x plus 3 times 4 equals 6. You still see it? Oh, we can't see, so I should probably do it over here. 6x plus 3 times y equals 6. That's a little better. We get 6x plus 12 equals 6. Subtract the 12. 6x equals negative 6. So x equals negative 1. So my final solution would be negative 1, 4. And you'll notice again we have a coordinate pair. That is a solution. So this will be classified as consistent independent. Now be careful of those tricky ones. If you're ever solving and your variables cancel out, your variables are gone after you add down with elimination or when you plug something in with substitution. If variables cancel out, look at what's left. One question you ask yourself, is it true? If you're left with a true statement, the solution is infinitely many. It is not all real, there's a difference. Infinitely many, meaning we have the exact same line, they intersect everywhere, which would classify as consistent dependent. Now, let's say that your variables cancel out and you're left with a false statement. Say 0 equals 5. We know that not to be true, at least I hope we do. That is classified as inconsistent because it has no solution. What kind of lines have no solutions? Parallel lines. If they never intersect, they do not have a solution, meaning it is inconsistent. Little refresher course on solving using substitution and elimination, systems of equations, go get it.